Select the correct statement for 50% reaction stage in a steam turbine. So 4 statements given to us are: the rotor blade is symmetric. Second is the stator blade is symmetric. Third is the absolute inlet flow angle is equal to the absolute exit flow angle. And fourth one is the absolute exit flow angle is equal to the inlet angle of rotor blade. Now for a 50% reaction turbine or 50% reaction stage in a steam turbine, so what happens here is enthalpy drop in the moving blade is equal to enthalpy drop in the fixed blade. Okay, and that is equal to enthalpy drop in this total stage divided by 2, right? And this type of turbine, let's say R is 0.5, that's the reaction stage of the steam turbine, and this type of turbine is called Pearson turbine. P-A-R-S, Pearson turbine. Okay. Now let's see the velocity triangle of this Pearson turbine. So this is the velocity diagram of a Pearson turbine. From the fixed blade, when the flow enters the rotor blade, this V1 is called absolute velocity of inlet. Okay. So let's write here V1 is absolute. I will write ABS for absolute velocity of inlet. Okay, and it enters at a velocity of V1 at an angle alpha 1. Alpha 1 is called absolute inlet flow angle. Okay, so let's write here alpha 1 is absolute inlet flow angle, and U is the velocity of blade, so the relative velocity will be VR1. So VR1 is called relative velocity of inlet, and this beta 1 is the inlet blade angle. Okay, so, or we can also call it as inlet angle of rotor blade. Okay, so beta 1 is inlet angle of rotor blade. It's right here, inlet angle of rotor blade. Okay. Also, the exit velocity of flow is V2. So V2 is also called the absolute exit velocity or absolute velocity of exit. So V2 is absolute velocity of exit of steam, we can say. And alpha 2, this alpha 2 is absolute exit flow angle. Absolute exit flow angle. And so beta 2 here is the exit angle of rotor blade. This is beta 2 is the angle of rotor blade when the flow is leaving this stage. Okay, so beta 2 we can say is exit angle of rotor blade. So for a Pearson turbine or 50% reaction stage, this velocity triangle is symmetric. Okay, so from here we can write alpha 1 is equal to beta 2 and beta 1 is equal to alpha 2. That also means from here we can also write this. Let's write here. So here we can write the V1, that is absolute velocity of inlet, is equal to the relative velocity, exit relative velocity. So VR2. From this diagram we can write, we can see here V1 is equal to VR2 and VR1 is equal to V2. That means the absolute velocity of exit V2 is equal to the relative velocity of inlet, so VR1. So in the problem the options are given Let's read out the options. So rotor blade is symmetric. No, so this is false. Option B is the stator blade is symmetric. This is also false. The absolute inlet flow angle is equal to the absolute exit flow angle. So this statement is also false. So the absolute exit flow angle is equal to the inlet angle of rotor blade. So we see here, from here we can write the option D is, we can choose that option D is the correct choice, right? So here this is alpha 2 is equal to inlet angle of rotor blade, that is beta 1. So option D is the correct choice. Now to study more on this Pearson turbine or steam turbine, you can refer to the NPTEL course lecture number 26, reaction turbine on steam power engineering by Professor Vinayak N. Kulkarni of the Department of Mechanical Engineering at IIT Guwahati.